Let f of x equals x squared plus 2x. Find the linearization L of x of the function at the point a equals 1. Well, the linearization formula is this. L of x equals f of a plus f prime of a times x minus a. If you're looking at that and thinking point slope thoughts, you're thinking correctly. Okay, but let's write out what we know. We know that f of a is going to be f of 1. So we'll say this, f of a equals f of 1. F of 1 is going to be 1 squared plus 2 times 1, which is going to be 3. All right, in order to find f prime of a, or f prime of 1, I have to find f prime of x, which is 2x plus 2 using power rule. So f prime of a is going to be f prime of 1, which is going to be 2 times 1 plus 2, which is 4. Also, a is 1. I can handle that. So writing out my formula, the linearization is going to be L of x equals f of a, which is f of 1, which is 3, plus f prime of a, which is f prime of 1, which is 4, times the quantity x minus a, x minus 1. And that's how you do it. For the function f of x equals e to the x, find the equation of the tangent line at x equals 0. Now, we have all this information from Unit 1, maybe Unit 2, how to do this, but this is the linearization section, so we're going to use the linearization information that we can come up with. So L of x is going to equal f of a plus f prime of a times the quantity x minus a. Now, when it says x equals 0, that's you basically saying a equals 0. It's the same exact thing. So let's find out what we can find out. F of a means f of 0. F of 0 is e to the 0, which is 1. F prime of x is going to get me my f prime of a. The derivative of e to the x is e to the x. So f prime of a is f prime of 0, which is e to the 0, which is 1 again. And since I'm calling a equals 0, I now have enough information that I can do this problem. All right, so they're calling L of x y, so let's call L of x y. F of a is going to be 1, plus f prime of a is going to be 1. X is x, minus is minus, a is 0. So y equals 1 plus 1 times x, which is y equals 1 plus x. So u. So again, we could have done this stuff using our old traditional methods, but they want us to use linearization here because linearization looks an awful lot like point-slope form. It's very, 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 very similar. In fact, it's almost the same exact thing, just with more derivatives and stuff, and so this method works just fine. Given the function f of x equals ln of x, approximate f of 3 using the tangent line at a equals 3. Well, we're going to do this using the linearization method. The linearization method says L of x equals f of a plus f prime of a times x minus a. All right, so let's see what we can find out. F of a is going to be f of 3. And this should have been a calculator section, but f prime of 3 is going to be 1.0986, which is why I pointed over here. I did that ahead of time. Doesn't mean anything, but it might mean something. I mean, the numbers, looking at the numbers ahead of time, I have a weird feeling about this. F prime of x is going to be the derivative of ln of x, so 1 over x, which means f prime of a is going to be f prime of 3, which is going to be 1 over 3. A is 3, and now we have all the information that we need. So L of x is going to equal f of a, which was that gross number, 1.0986, plus f prime of a, which is 1/3, times, now they want us to find f of 3, which means x is 3. So 3 minus a, which is 3. So that is going to become 0, and a third times 0 is that, which means L of x is going to be that. So kind of a bizarre problem, but that's what we end up with. So that's how you can do it.